The first thing that we're going to do is we're going to start our process of breaking a polynomial down into its factors. Because if we can factor it into smaller pieces, those smaller pieces are a lot easier to work with than this really large polynomial there. So that's what the idea is, what we're going to do. And we're going to start off with a little bit of help. And they're going to give us a factor, or they're going to give us a zero. Kind of like what we were doing in that lab where they gave us k equals a number. We had to decide if it was a zero or not. We're going to start out with that kind of idea here, and we're going to use that to help us break down a polynomial further. So with this first one, what we're going to be looking at is taking this polynomial that's 3x to the fifth minus 2x to the fourth plus x to the third minus 8x squared plus 5x plus 1. And we're going to take that polynomial and try to break it into a smaller piece by using x minus 1 as a factor out of that. So one of the statements that we need to kind of tie together here is that if k, or some number, is a zero, then x minus k is going to be a factor. Okay? So here we have x minus 1. What's k in this case? 1. The opposite of that. So you're always going to flip the sign. That's the idea that I want you to catch. Just flip the sign out. So what we're going to do is we're going to start by taking the polynomial and we're going to break it down using a 1 on the shelf. Our value that we're from the factor that they gave us tells us, and the way that we could do that if we didn't know what we were, really know the shortcuts, just change the sign. We could set that equal to 0 and solve it, and that 1 is what goes on the shelf. If we don't know that shortcut is just change the sign, and that's what goes on the shelf. Then put your polynomial in there. So we got 3, -2, 1, -8, 5, and 1. And we're going to run synthetic division on this to try to break this polynomial down and prove that x minus 1 is a factor. So drop the 3 in and multiply, add, multiply, add, multiply, add. 1, and there's the 0 in that spot. What that tells us is that x minus 1 is a factor, and the way that the polynomial starts factoring is we get this x minus 1, and then what happens when you do synthetic division is it takes this polynomial from the degree that it starts out with. The degree is the highest exponent on x. Fifth, we go down 1 because we're divided by something that was just a plain x. So this is x to the fourth, x cubed, x squared, plain x, and the constant. That works if the remainder is 0. Okay, so it takes this polynomial and makes it smaller, which makes it a little easier to work with as we go forward from there. So we got 3x to the fourth, that's x to the third, 2x squared, which is not small, but it's smaller than what we started with. And then we're going to learn some skills as we go along here and what we can do with that and find out how can we break that down further. So the starting fact is we're going to check it with synthetic division and see if it's a factor. If it is, it's going to break the polynomial down a little bit for us. If it's not a factor and it doesn't help us. Okay, so we're checking to see if it's a factor to help us do that. So example B, let's take a polynomial, 2x to the fourth, 2x to the fourth, plus 3x squared minus 5x plus 7. And we're going to check x minus 1 on it and see if it's a factor of that polynomial. If it is, it'll break it down a little bit. If it isn't, then that means we got to do something else. We'll learn how to do that as we go through this evening. So what goes up on the shelf? 1, 2, 3, -5, 7. Oh, what am I missing? A 0 where? Yeah, between the 2 and the 3. Because we're missing what part? X to the third, yeah. So 3, -5, 7. Be careful of that because that could mess you up on deciding if it was a 0 or not. It might make you think it is a 0. It could make you think it's not a 0 when it actually is. If you leave out that 0. So be careful of that. Drop the 2, multiply, and add. And 7 plus 0 is 7, not 0. So we know that x minus 1 is not a factor because the remainder wasn't 0 at the end. There's a 0 right there, but that doesn't matter. It's what's happening at the very end. So that not being a factor means, hey, we'll have to try something else. We're going to learn how to find out what other things we should try as we go through this evening. So let's look at some where they tell us ahead of time. They say factor completely. So we were just checking a factor on example A and B. Let's take a polynomial and try to break it down into its smallest components using factoring and synthetic division together. So we're going to have to remember all those rules about factoring, about GCF and grouping and X method, those things that we did back a month or two ago, a month and a half ago or so. So let's look at this polynomial. F of x equals 6x cubed plus 19x squared plus 2x minus 3. And they tell me x plus 3 is a factor. So they're being nice and telling me, hey, that's a factor. No question, that's a factor. So what does that mean the remainder will be when I do synthetic division? 0. If it's anything else, I know I did something wrong because they told me it was a factor. I know I messed up somewhere if I don't get 0 in the remainder. So I'm going to take that polynomial and I'm going to do synthetic division. 6, 19, 2, -3. What goes on the shelf? -3. Flip the sign. Drop the 6 in. There's that remainder of 0, which is what I wanted. Okay. What that does is it takes that polynomial and breaks it down into x plus 3 as a factor. And then we went from an x cubed down 1 degree. So this is 6x to what power? Squared. And then this would be 1x. This would be minus 1. So the next parenthesis is 6x squared plus 1x minus 1. It said factor completely. So what I'm going to try to do is factor this piece using the X method thing that we learned a while back. So I'm going to set up the X. 6 times -1 is -6. And it's got to add to be +1. Multiply to be -6 and add to be +1. -2, +3. Good job. So I'm going to put that in there. And group it. First two together. What's the GCF of 6x squared and -2x? 2x, wouldn't it? 3x minus 1. Those two, there's nothing else in common, so I pull out a 1. X plus 3 still there. And now we finally get the factored form. x plus 3, 3x minus 1, and then the stuff in front is 2x plus 1. That is your factored form. That's what that is. So you're taking a polynomial. They told us one of the factors. We use synthetic division to take that factor and break the polynomial down a little bit to get it into something that we knew how to manage and to work with. Okay, so got it down to that quadratic, and then we could factor that from there. So we're going to look to factor that quadratic if possible. That doesn't mean it always will, but we're always looking to see if it will. Okay. All right. Let's do another one. X to the third plus 4x to the second minus 5. X minus 1 is a factor. So here they give us a factor, and they want us to factor that polynomial completely. So set up synthetic division. It's what your first step's going to be every time. One, 4, 0, -5. The 0 in there because we're missing the plain x. What goes on the shelf? Positive 1 this time. All right, so drop the 1 in and go. And there's that 0 in the remainder like it's supposed to be. We know they told us it was going to be there when they said that that's a factor. So that takes my polynomial to what two pieces? What are the two pieces that the polynomial is now? X minus 1, the one they told us about. And what's the long one that's left over here? X squared plus 5x plus 5. Okay, so this looks a lot like the previous example. That's a quadratic. It's got 3 terms in it, so I'm going to try to factor that using the x method. We need something that multiplies to be 1 times 5 is 5, and the 5 in the middle. What is there anything that multiplies to be 5 and adds to be 5? Well, the only things that multiply to be 5 are what? 5 and 1, or -5 and -1, right? Do either of those add to be positive 5? No. So that doesn't work. So that means that's completely factored. You've got to try to factor it. It doesn't mean that it always will, but we got to try to see if it will. So this is our factored form for this one. It didn't go further. We tried to make it factor a little further, but it wouldn't do it. So that's what we've got to look for is can it be factored? If it can, do it. If it can't, then that's all you can do. Okay. So this is given a factor in the polynomial. Let's take it a little step further, a little closer to where we're headed. Let's factor given a 0. Here's a polynomial, 2x cubed minus 3x squared minus 5x plus 6. K equals 1 is a 0. All right. So if they say K equals 1 is a 0, that means when I do synthetic division, what goes on the shelf? 1. You don't flip the sign. When they tell you a 0, the sign's the same. This is like the lab we did. It's exactly the same thing. Okay, they're just telling it's a 0. We're not having to prove that it is. Okay, so factor, you got to change the sign. If they tell you a 0, don't change the sign. Okay, so that's where it gets a little confusing depending on what they give you. So I'm going to set up synthetic for using the 1. Drop the 2 in there. And surprise, surprise, I got a 0 in the remainder. Actually, it shouldn't be a surprise at all. They told us it was a 0. We knew that should have been there. Okay. Now, here's the trick, or the part some people kind of mess up on with this. What's the little short factor that we know of? X minus 1. If 1 was a 0, x minus 1 had to be a factor. And then what's left here? What's this part? 2x squared minus x minus 6. And that's a trinomial, quadratic. I'm going to try to factor that with the x method. See if it'll go further. Because I'm still trying to factor this polynomial as far as it'll go. So what goes on the top of the x? Combination of the two. 2 times negative 6 would be negative 12. Goes up there. And then negative 1 goes in the bottom. Multiply to be negative 12, add to be negative 1. Does anything do that? Negative 4 and negative 3 and positive 3. There you go. And then because there's something in front of x squared, I got to do the grouping step. So I'm going to do minus 4x plus 3x minus 6 and group that. What's the GCF of my first group? 2 what? 2x. And what's that leave in its parentheses? X minus 2. And then what do I pull out of the second pair? Positive 3. And that leaves us x minus 2 in there. So my factors are x minus 1 and then x minus 2 from the matching parentheses. And then the stuff in front was 2x plus 3. So we were able to take that polynomial and break it down into 3 really manageable factors out of that. We got the factored form. This is completely factored. Ways that you can check to see if your factored form is the right one would be if you graphed the original problem with your calculator. So I went 2x to the third minus 3x squared minus 5x plus 6. If I graph that, there's the picture of it. And I go to y2, and I'm going to type in the factored form. X minus 1, x minus 2, 2x plus 3. All of those in parentheses. It should land exactly on top of it perfectly. If it doesn't, then our factoring's wrong. It covered it right up. That means we did it exactly right. Okay. If it doesn't cover it up, then or lay right on top of it, then you know it's wrong. You got to try to go back and fix it. Okay. So factored form, that's what we're trying to get there. All right. Now, once we get it in factored form, we can get the zeros of a polynomial. What's another name for zeros of a polynomial? Does anybody know? We did it with quadratics. They were zeros of a quadratic, and there was another name for them. There was some kind of intercept. You got a 50-50 shot here because there's only two kinds of intercepts we've talked about. They are X-intercepts, okay? X-intercepts and zeros are exactly the same thing, okay? And if you're an X-intercept, where are you on the graph? Look, since we've graphed this one already, where are the X-intercepts? Across the X-axis. That's the key, okay? Now, what do we know about the ordered pairs for X-intercepts? No matter what kind of equation we have, if it's an X-intercept, the ordered pair always has what in the Y place? 0, okay? In order to find the zeros of a polynomial, you set the factors equal to 0 and solve. So if we extend this problem, we've got the factored form and we want to find the zero, so we'll make this example F. Find the zeros of f of x equals x minus 1, x minus 2, 2x plus 3. All we've got to do is take each factor and set it equal to 0 and solve it. X minus 1 equals 0, x minus 2 equals 0, and 2x plus 3 equals 0. Get x by itself in each one. X equals 1, x equals 2. Third one's a little tougher. 2x equals negative 3. Divide by 2. Get a fraction. Negative 3 over 2. We got 3 zeros of that polynomial. Positive 1, positive 2, and negative 3 over 2. Let's go back to the graph that we used earlier and look at the relationship between these numbers and where it's crossing the x-axis. It's crossing the x-axis at positive 1. This is positive 2. And what's negative 3 over 2 as a decimal? Negative 1.5. Here's negative 1, here's negative 2. That's right there halfway in between, right? So the places that it crosses with the graph should be the zeros of the polynomial, okay? This would happen to have 3 nice ones that are rational numbers. They're not always nice and pretty like that, but the idea of the connection between the graph and the zeros is exactly that. If it's crossing the x-axis, it's got a 0 at that spot where it's at. And that's going to be handy as we kind of build up to later on, what if they don't give us anything except for a polynomial and say find the answers? Well, we know some relationship between a graph and the answers, so that's going to help us later on. So tie that together and keep that in the back of your mind that that's what's happening. Let's look at one of the problems that we've already kind of done. Let's find the zeros for f of x is equal to x cubed plus 4x squared minus 5 if x equals 1 is a 0. So they're telling us if x equals 1 is a 0, find the rest of them, okay? So I would set up my synthetic division and run the synthetic division to break this polynomial down. They gave me one of the zeros. There should be 2 more to find because the degree is 3. Those are always the same. 5. And there's that 0 remainder. I expected that because they said x equals 1 is a 0. So I have the factored form, x minus 1, x squared plus 5x plus 5. This is the one we had done earlier, and we tried to factor that and multiply to be 5 and add to be 5, and nothing worked. And that's where we run into problems. Okay, well, now we got to remember some of the other stuff that we did with quadratics. If it wouldn't factor, what was our option for solving it? Quadratic formula. And here's the beautiful thing about the quadratic formula is, even if it will factor, the quadratic formula still works. If it'll factor, it's probably easier to factor it than it is to do the quadratic formula, because there's less simplifying, a lot less signs and operations to do. But if it won't factor at all, you have to do the quadratic formula to solve it. So we're going to solve this problem using the quadratic formula. We set x minus 1 equals 0, get x equals 1. That's one of our zeros. When we set x squared plus 5x plus 5 equal to 0, that's where our quadratic formula comes in. And we got to have a, b, and c to do that. So that's 1, 5, and 5. Remember doing quadratic formula, we did the discriminant part first because it made things a lot easier. So I got 5 squared minus 4 times a times c. So it's going to be 25 minus 20, which is 5. Okay, so the discriminant, which is the part that goes underneath the square root, tells you what kind of solutions you're going to have. If it's positive, you're going to have real solutions. If it's negative, you're going to have complex solutions. Remember that. If it's equal to 0, then you're only going to get one answer out of it. Okay, so here we get a positive number, so we're going to get 2 real solutions. So I'm going to set up my quadratic formula. So negative b, so it'll be negative 5 plus or minus the square root of the discriminant divided by 2 times a, which a was 1, so that'd be just 2. I have 3 answers here. One of the answers is the one they gave me. 1. They told me that at the beginning of the problem. 1 was a 0 in this problem. So that's the one I knew about. This is 2 answers here. Negative 5 plus square root of 5 divided by 2 is a solution. And then negative 5 minus the square root of 5 over 2 is a solution. Let's look at the graph of that polynomial to kind of relate this back together. Because we have 3 real solutions to this, that means this thing should touch or cross the x-axis 3 times. Okay? So I'm going to graph it. Go back to the original polynomial and graph it. So x cubed plus 4x squared minus 5. There it is. Look where it's crossing the x-axis. Right over here is the positive 1. These 2 over here, one of them is the negative 5 plus the square root of 5 over 2. The other one is the negative 5 minus the square root of 5 over 2. Those are what those are. We found 3 real solutions. It crossed the x-axis in 3 spots. If you have 3 real solutions, that's how many times it'll cross the x-axis. If you have complex solutions, they don't touch the x-axis. Okay? Keep that in mind. Real solutions hit the x-axis. Complex solutions do not. And we'll get into those as the evening rolls on. Okay? All right. Let's take another polynomial. F of x is equal to 4x cubed plus 6x squared minus 2x minus 1. X equals 1/2 is a 0. So they're throwing a fraction at us. That's okay. They're being nice. They gave us a 0. So we know that if we do synthetic division with that 0, we're going to get a remainder of 0. I'm going to put the 1/2 on the shelf and start breaking that polynomial down. X cubed, X squared, plain X, plain number. Make sure I got everything. This one's not so bad. The fraction looks intimidating because we don't like working with fractions, but we're just taking half of whatever number we're multiplying by. So drop the 4 down. What's 4 times 1/2? 2. That's pretty easy. 6 plus 2 is 8. So we're multiplying 8 times 1/2. It's half of 8. It's 4. Add 2. 2 times 1/2. Half of 2 is positive 1. And there's that remainder of 0 out of that. Okay? Now, that opens up the factoring idea. And then this is where some folks kind of get confused on the factoring. Not 8, 6, but 8x plus 2. And then you'd have x minus 1/2 right there. That'd be that factor. Now, I'm going to try to factor 4x squared plus 8x plus 2 with the x thing. I don't know if it will or not. Multiply to be 8 and add to be 8. It's kind of hard to do, right? 8 times 1 is 9. 4 times 2 adds to be 6. And then we're out of options. So that doesn't work. So if it won't factor, what do I have to do to find the other zeros? Quadratic formula. So no factoring means quadratic formula. So I'm setting 4x squared plus 8x plus 2 equal to 0. I also did that with the 1/2, but I already knew that x equals 1/2. I don't really have to do that work. So discriminant 8 squared minus 4 times a times c. So if you didn't have that learned already, you better get with it and learn that. 4 times 4, 16 times 2, 32. 64 minus 32, 32. A positive number. So that means we have 3 real solutions to this. Negative 8 plus or minus the square root of 32 over 2 times 4. I'm going to simplify the square root of 32 by breaking down 32. 8 times 4, 2 and 2, 4 and 2, another 2. So 2 pairs of 2s. It's going to be negative 8 plus or minus 4, square root of 2 over 8. What do I know about each of these numbers? Four goes into all of those, so I'm going to divide them all by 4. Only the numbers that are on the outside of the radical can you do that with. Okay, so divide them all by 4. That's going to be negative 2 plus or minus 1 radical 2 over 2. You know, 1/2. And then 2 plus square root of 2 over 2. Negative 2 minus square root of 2 over 2. So that's 3 answers. We had a polynomial at the beginning, had degree of 3. The highest exponent was 3. So we had 3 answers. That always goes together. 3 solutions for a cubic polynomial. It has a degree of 3. All right. So far, they've been really nice to us, and they've either told us one of the factors or they told us one of the zeros. What happens when they take that away and Dad's got out there and he's taking the training wheels off your bike and you've got to ride on your own now? Whereas my older brothers did. They took my training wheels off and then pushed me down the hill, and I had to learn to ride. It worked out. I didn't die. Here they're taking the training wheels off. When they take the training wheels off, we've got to have a little bit more skill and to know what to do. And that extra piece of skill that extra balance to ride the bike comes from what's called the rational zeros theorem. And the rational zeros theorem gives us some clues as to what the zeros could be for a polynomial. Doesn't tell us what they are, but it narrows it down from every number in the entire universe to a certain set of numbers that could be zeros to the polynomial. Doesn't mean that they will be, but it means that they could be. So I would rather have a list this long as opposed to a list that's a whole length of this room long. That's in comparison to every real number to a smaller list. So here's how it works. P over Q is a rational number and a zero of a polynomial. We'll call that polynomial f of x. Then P is a factor of the constant term and Q is a factor of the leading coefficient. Okay. All right. That really doesn't mean a whole lot until we do a problem that's got some actual numbers to it. But what it boils down to is you can take the number at the end and the number in the front and look at the factors that go into those to make a list, a shortened list of the possible rational zeros. Rational numbers are numbers that can be written as fractions. They're real numbers, not complex. Okay. So when we're doing the rational zeros theorem, we're trying to find real numbers. So real numbers do what to the x-axis on graphs of polynomials? Do real numbers cross the x-axis or not? We just talked about this. Real numbers do cross the x-axis. So this is going to tie us back to the graph idea. Okay. So let's get an example and let's talk about the P over Q list. I don't know what letter we're on here. I. Example I. Here's our polynomial. F of x is equal to 6x to the fourth plus 7x cubed minus 12x squared minus 3x plus 2. All right. This is P. This is Q. That's where the P and the Q come from. Okay. So we're looking at the number 2 and the number 6. P over Q. So we need the factors of 2 over the factors of 6. All right. So what's it mean to be a factor of 2? Not necessarily. What's it mean to be, just think about the number. It has nothing to do with the polynomial. What's it mean to be a factor of another number? Not a number that 2 will go into, but a number that will go into 2. Okay? So when we talk about factors of 12 are 1 and 12 go into 12. 2 goes into 12 6 times, right? So 2 and 6 are factors. And then 3 goes into 12 4 times. So 3 and 4 are factors of 12. So here, the factors of 2 would be 1 and 2. And I'm going to put a plus or minus in front of that because technically it could be positive 1 that goes into it or it could be negative 1 that goes into it. They both divide evenly into 2. So the factors of 2 are plus or minus 1 and 2. What are the factors of 6? Obviously 1 and 6. 3 and 2, right? So it could be a positive 2, could be a negative 2 out of that. Now, here's how we're going to make our list. The list is taking the factors of 2, the top part, and divide each one of those factors by every one of these. Right? So 1 divided by 1. What? 1. 1 divided by 2. That's 1 divided by 2 is 1/2, right? So I've got plus or minus 1, plus or minus 1/2. 1 divided by 3 would be plus or minus 1/3. 1 divided by 6 would be plus or minus 1/6. Then I do the same thing with the 2. 2 divided by 1, 2. 2 divided by 2, 1. I already got that wrote down. I'm not going to write it again. 2 divided by 3, 2/3. 2 divided by 6, 1/3. I already got that wrote down, so I'm not writing it again. Okay? So what I've done is I've created this set of rational numbers that are the possible rational solutions for this polynomial. Instead of every number in the world, I've narrowed it down to 12 numbers. It's a much smaller list. Now, you guys have an advantage. You're growing up in the era of graphic calculators. I didn't grow up in that era. We had to just guess. Pick one of those and try synthetic division and see if it worked. If it didn't, start over. Guess another number. You guys have a graphing calculator, and this is where the graph comes back in. So what we're going to do is we're going to graph this polynomial with our graphing calculator. That's the next step. The P over Q list, I will guarantee you, quiz question, test question, final exam question. Making the list is on the final. At least one question, if not 2. Every year, always. Doesn't take a ton of talent to do that. Okay, we're going to do that for every problem we do from here on out in math in this class. So we'll get some practice at it. All right. So the first thing you're going to do is you're going to make that list, and then we're going to graph the polynomial to try to get a clue as to where to start at instead of just guessing and checking like what I had to do. All right. So go to y equals, clear out that polynomial that was in there, and then type in this one, 6x to the 4th plus 7x to the 3rd minus 12x squared minus 3x plus 2. 6x to the 4th, 7x cubed, negative 12x squared, negative 3x. Okay. I'm going to hit graph. I'm looking for where it's crossing the x-axis. And I'm looking for a good number that's easy to do math with. All right? So when I look at that, I've got it crossing the x-axis how many times? 4. So that means I should end up with 4 real solutions to this. What was the degree of the polynomial? 4, right? I'm going to get 4 answers. This happens to be 4 real answers. No complex. Okay? So when I look at that graph, I see it crossing the x-axis at some nice places. What's this place right here? -2. Is -2 in our list? Okay? What's this place right here? +1. Is +1 in our list? Yeah. Now, what could this place be? It's between 0 and 1, so it's one of those smaller fractions, right? So what fractions do I have that are between 0 and 1? 1/2, 1/3, and 2/3. Does it look like it's halfway between 0 and 1? No, it's a little closer to 0. Well, I'm assuming that might be 1/3. I can verify that in a little bit. This one, that might be -1/2 there. That's what it kind of looks like. Okay. We're going to do synthetic division with one of these good ones, though. It's one of the easier ones. It's not a fraction. It makes it a little easier. So I'm going to start with this easiest one, the positive 1. Do synthetic with it and see if I get a 0 as a remainder. So make your P over Q list, graph, look for X-intercepts. We saw one at 1, and I'm doing synthetic with 1. Six. And what do you know? There's that remainder at 0. Okay. So we verified that it looked like it was crossing at positive 1. We verified it with our synthetic division that it is. So we have a 0 at x equals 1. What did it do to our polynomial? We started at x to the 4th power. This becomes x to the 3rd power. It goes down 1, right? Now, I don't have a lot of stuff that I can do with x cubed problems, right? I've got a couple of different tools that I can use for x squared problems, but I don't have much I can do for x cubes. So what I'm going to try to do is break this down one more time. Do I have another good number that it crossed the x-axis at? That -2, right? So I'm going to do synthetic division on that with the -2. Drop the 6. There's that remainder of 0. Okay? So I've done synthetic division twice. I didn't start over. I didn't go back to the original. I took what's called the quotient and did synthetic division on it. Because I'm trying to make the polynomial smaller. So I started with x to the 4th. This is x to the 3rd. That means this has to be x squared. Now I've got it down to a quadratic. And I've got either quadratic formula or factoring with the x method that will help me do this part. Okay? So I got a 0 at x equals 1. What's the other 0 I just verified? -2. So I'm going to take 6x squared plus x minus 1, set it equal to 0, and I'm going to try to solve it either by factoring or by quadratic formula. I think it'll factor, multiply to be -6, and add to be +1. Be 3 and -2, wouldn't it? So this one will factor. That's nice. I like it better when it factors than I do quadratic formula. So I'm going to set it up 6x squared plus 3x minus 2x minus 1 and group those. These are not short problems. It is really the culmination of everything we've done this semester coming together. -1. So we have 2x plus 1, 3x minus 1. And then what do I do with each of those factors? Set them equal to 0. -1/2, 1/3. So I get x equals -1/2, x equals 1/3. All of my zeros are right there for that polynomial. They were all real numbers. We looked at the graph. Didn't we kind of estimate that we thought it crossed at 1/3 and we thought it crossed at -1/2? Tie together the graph with the zeros. When they're all real zeros, you should be able to see them happen there. They're all real and rational. It's much easier to see. We don't always see it if it's got to be solved by quadratic formula, but they're there. Okay. Let's look at this one. G of x. Let's
change the name of the function, x cubed plus 5x squared plus 2x minus 8.
How many answers should I get when I get done with this? 3. How do I know that? The first x, the highest exponent is 3. That means I get 3 answers. Okay. Now, let's make our P over Q list. This one's a little easier because you don't have a number, and you got a 1 in front of x cubed. So remember, this is P, this is Q. So the P over Q list, you got to have the factors of 8. What are the factors of 8? 1. What else? 2 goes into 8 4 times, right? And then 8 goes into itself. So plus or minus 1, 2, 4, and 8. And then on the P, that's for P. For Q, we got 1, and it's just got plus or minus 1 as a factor. That makes the list super easy because when you divide 1, 2, 4, and 8 by 1, you get the same numbers back. So our list is plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Because we don't have any other factors in the denominator to divide by. So we've narrowed this down from every number in the universe to a set of 8 numbers this time that it possibly could be. Doesn't mean it will be any of those, but if they're rational solutions, it will be one of those if they're rational zeros. Okay, so what's the next step that we did? After we made our P over Q list, we did what with the polynomial? We graph it. Okay, that's the next step, is to graph it. That helps you pick what to put on the shelf for your synthetic division. Instead of just guessing one of these 8, we got a 3 in 8 chance of picking the right one. That's pretty good odds, but there's 5 out of 8 chance we're gonna pick a wrong one. That's not good. All right, so graph it to get a clue. Okay, so x cubed plus 5x squared plus 2x minus 8. So I'm gonna graph that thing. X to the third plus 5x squared plus 2x minus 8. Hit graph. We're looking for a good place where it crosses the x-axis. This one looks like it crosses in 3 pretty nice places. So we're going to do synthetic division with whichever one we like the best. Which one do we like the best? 1's the easiest math, right? It would work if you used either of the other 2. So it's crossing at 1. Looks like it's crossing at -2 and -4. We're going to use 1 in synthetic division just because it's easier math. If you use -2 or -4, it still works. Doesn't matter which one you pick to use first. Pick your favorite. I'm going to pick 1. Drop it in there. And what do you know? Get a 0 in the remainder. So our zeros over here, we got x equals 1. And that broke that down into a quadratic, x squared plus 6x plus 8. That'll factor. And it's got a shortcut on the factoring. There's nothing in front of x squared. So that's going to give us x plus 4 equals 0, x plus 2 equals 0. There's the -4. There's the -2. And all 3 real solutions, all 3 rational solutions, we saw them on the graph. That's what I want you to tie together. You can see this stuff if they're real solutions on the graph. They always show up that way. All right. Let's look at this one. Let
can make up a better one. I don't like that problem. All right, here we go. F of x is equal to x cubed plus 9x squared plus 24x plus 20. There's our polynomial. All right, it's in descending order. We're going to make our P over Q list to get the practice. Even though we know some shortcuts, we can just go straight to the graph. We want to know how to make this P over Q list because they're going to throw me some easy points on the final exam if I can do this. So factors of 20 are what? We always start with 1. So what's next? 2, 4 goes into 20, 5 goes into 20, 10 goes into 20, and then 20 into itself. And then Q is 1, so is there any need in doing the bottom part? No, we just know that there's plus or minus in front of each one of those. So we've narrowed it down already to those. So the next step is to do what with the polynomial? Graph it. X to the third plus 9x squared plus 24x plus 20.
All right, this one looks a little bit different. It's similar to the ones we've done already, but it's got one key difference that I want to point out to you. Where is it crossing the x-axis? At -5. What's happening right here at the -2? Is it crossing it? No, it's going down to it, touching it, and then going back the other direction, right? It's bouncing off of it. Anytime you see that happening, what that tells you is that this is a 0, but it has an even multiplicity is what it's called. It means it counts more than once. Okay? Even multiplicity, this is going to count, since we've got a cubic one, it's got third degree, it's going to have 3 zeros. One of them is this -5. The other 2 are both -2. Okay? Let's look at it, and I'll show you. Let's break down the polynomial using synthetic division, and I'll show you where that's coming from. So let's use that -5 in our synthetic division to start off with, because we know that for sure it crosses the x-axis right there. So I'm going to drop that 1 and go to work. And there's the 0 in the remainder, just like I wanted. And I've got -5 as a 0. What I've got left is a quadratic. Multiplies to be 4 and adds to be 4. 2 times 2. Shortcut to factoring, x plus 2, x plus 2. Notice that that factor shows up twice, right? So when I solve x plus 2 equals 0, I'm solving it twice. So I get x equals -2, and the way we note that is we say multiplicity of 2. That means it showed up twice. If it showed up 3 times, you'd say multiplicity of 3. This is how you would write your solutions or your zeros there. Got -5, x equals -2, with a multiplicity of 2 because it shows up twice. Even multiplicities bounce off the x-axis, like this one did. Odd multiplicities go through the x-axis. Okay? Even multiplicities bounce off the x-axis. You might want to write this down. So even multiplicity bounce off the x-axis. Odd multiplicity cross the x-axis. Okay. If the even multiplicity is 14 times, it still bounces off the x-axis. If the odd multiplicity is 1, it only shows up once. Like this case, the -5 only showed up once. That's an odd multiplicity. It crossed the x-axis. If it shows up 3 times, if we had x minus 5 or x plus 5 as a factor 3 different times, then it's still got an odd multiplicity and it crosses the x-axis. Odd multiplicities always cross, even multiplicities always bounce. Always. Okay? So multiplicity comes up, those kind of things are going to be a big part of that. Okay? All right. So far, everything that we've done has had real solutions. And it's crossed the x-axis the same number of times as the degree. That doesn't always happen. Okay? But the process of getting your solutions is still the same. Okay? So let's start looking at some polynomials that don't necessarily, I have no idea, L. On example L. This, I guess. I've gotten off from my notes here. So we're going to find all the zeros for a polynomial. Let's say it's x to the 4th power minus 7x cubed plus 18x squared minus 22x plus 12. Okay, so a nice 4th degree polynomial. Its highest exponent is 4, so that means we're going to find how many solutions? 4. Whatever the degree is, highest exponent, that's how many zeros you're going to have. That doesn't necessarily mean it's going to cross the x-axis that many times, but that's how many answers you're going to find. Always. Okay? So let's look at this one. Let's do our P over Q list just to get the practice because it's just 12 and that won't take us long to do. And the leading coefficient's 1, so we don't have to do much, no fractions on this one. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Factors of 12, we know those already. Okay? So the next thing that I do with my polynomial is what? Graph it. I'll set it up for synthetic, and I'm hoping that the graph will give me an idea of where to start with this thing. So I'm going to y equals x to the 4th power minus 7x to the 3rd power plus 18x squared minus 22x plus 12. Just checking all my signs to make sure I got it written down correctly. And then I'm hitting graph. And this one, I get the picture and I see it crossing the x-axis how many times? Only 2 times. Right here and right here. That's not 4 times like what we've been seeing. So what that tells me is that looks like I've got 2 real solutions, and then I'm going to have a couple of complex solutions. Because complex solutions don't cross the x-axis, only real ones. So what would be one of those? Where's it crossing the x-axis at? What's the number? 2 or 3, right? So I'm going to use one of those. I'm going to use 2 first. Doesn't matter. I'm going to use 2 to do my division with first. So I'm going to put 2 on the shelf and run my synthetic division with the 2. And there's my 0 remainder. So my zeros
get x equals 2.
What that did is it took my 4th degree polynomial, and this is now a cubic polynomial, x cubed. I don't have a lot of tools to use it on x cubed problems. So I want to do that again. What's the next number that I need to do synthetic division with? 3, the other place that it crossed the x-axis. So I'm going to do synthetic division with a 3 this time on what's left. And there's that remainder of 0. I said 0 and wrote it. 3. All right. Now, that got us from 4th degree, 3rd degree. What's this? 2nd degree is quadratic. That opens up factoring, quadratic formula, all that stuff that we're supposed to know how to do. So we're going to do quadratic formula on this because I don't know of anything that multiplies to be 2 and adds to be negative 2. So I've got x squared minus 2x plus 2 equals 0. I'm doing discriminant. It'd be 4 minus 8, which is negative 4. Hey, that's a negative number in the discriminant. That tells me that it's got complex answers. That's where that comes from. Okay. This equals negative b, so that'd be positive 2 plus or minus the square root of negative 4 over 2 times 1 is 2. What's the square root of negative 4? 2i. Good job. And good news is everybody that's not in a radical, all those are divisible by 2. So divide them all by 2. So that's going to be 1 plus or minus 1i or just i. So I have x equals 1 plus i, x equals 1 minus i, or you could write it 1 plus or minus I. I don't care which way you write that. But that's all 4 solutions to that. 2 real ones. We saw they cross the x-axis in 2 places. That's the 2 real ones. Then 2 complex ones. Those complex ones kind of show up. You saw that graph. If you look at the graph of that, see how it's got a little bit of wiggle down here? Right in that little place. That kind of can tell you the complex ones are making that happen. Can't really find them on the graph because this is the real number coordinate plane, but we know they exist. It's that whole bad naming accident thing that those mathematicians did when they named them imaginary numbers. Such a horrible name, but it works, and it's what stuck. It's kind of like when Adam called them cows. What if he'd have called them parakeets? It'd been weird, but it would have been what we were used to. So, all right. So complex solutions in that one. Let's look at going the other direction. I know y'all are getting tired. This is pretty heavy lifting. So we got 1, 2, 3, 4. Give me about 8 more things and we'll be out of here. All right. So I know you're tired. I'm tired too. Long day. All right. Got the M. So we're not going to take a polynomial and break it down. We're going to take the solutions or the zeros of a polynomial and make a polynomial. Okay, so we're going to form a polynomial of degree 3 that has zeros of -1, 2, and 4 with f of 1 equal to 3. All right. Weird problem. Okay. So here's the big picture out here. We're going to take what do we know about zeros and a polynomial? Well, zeros, since these are the zeros, they came from factors of the polynomial, right? So what's the factor that goes with -1 being a 0? This goes back to where we started this evening. What's the factor that goes with -1? X plus 1. Good job. What's the factor that goes with +2? X minus 2. What's the factor that goes with +4? X minus 4. All right, so that gets us the factors. We've used 3 of the 4 things they've given us. We haven't used this part yet. And this is where this part is the tougher part out of this. So here, what does this 1 represent? And what does this 3 represent? The 1 is the what? X, and the 3 is the Y. Okay, so this is an ordered pair here. Okay? Here's where that comes in. There's always this leading coefficient in the front. And it's A is the letter we usually use for that. Just because X is already taken. Okay, we're just going to put A in front. Now, this is what we're going to use to find out what A is. I think it's easier to find out what A is before you multiply all this stuff out. So that's when I do it. Because I can plug this in the place of X and this in the place of Y and work that out. Okay? If I do that, if I plug in 1 for X and 3 for Y, where's Y at in this problem? What part of all of this is Y? F of X is Y. So I'm going to replace F of X with 3 that's over here. We'll put a 3 there. I don't know what A is, but I know X is 1. Oh, 1 minus 2. And then 1 minus 4. Now, all I got to do is multiply that all out. So that's 1 plus 1, that's 2. 1 minus 2 is -1. 1 minus 4 would be -3. 2 times -1 times -3 would be +6. Well, that turned into an easy problem. A is 1/2. Okay. Now, all of that work to get just the thing that goes in the front. Okay. So right now, the polynomial that we have is f of x is equal to 1/2 parentheses x plus 1, x minus 2, x minus 4. We need to multiply that out to get it into standard form or descending order. Okay, that's the final answer that we need to get with. Okay, so we're going to multiply this out. I'm going to multiply these 2 together first. It doesn't matter which 2 I multiply together first. I'm just picking 2. You pick your favorite 2 if you want to. These are my favorite 2. That's the ones I'm going to do. So x times x is x squared. X times -4 is -4x. -2x. +8. I'm going to wait and do that fraction very last. I don't want to mess with fractions until the very end. Okay. So I'm going to simplify that a little bit. X squared minus 6x plus 8. And I'm multiplying that by x plus 1. So x times x, x cubed. X times -6x, -6x squared. Plus 8x. Then multiply the 1. X squared minus 6x plus 8. All right, fun stuff, right? X cubed minus 5x squared plus 2x plus 8. Okay, I'm just combining like terms at that step. -6x squared positive 1x squared is a -5x squared. 8x minus 6x is 2x. 8 didn't have any alternatives, so it's right away. X cubed didn't have any alternatives, so it's right away. Last step is multiply that half to everybody. And you're done. Finally.
1/2 x cubed minus 5/2 x squared plus x plus 4.
And you built a polynomial, given some zeros, and another point on that polynomial. Not easy, not short.
A lot of operations there that could have been messed up. If we count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 operations to get there. Be careful. Takes patience and just close looking. All right, let's look at another one. Definitely in. Here are our zeros. -2, multiplicity of 2 and 3. And we'll take a shortcut on this one and say A equals 1. And we'll go back to it. Okay. So we got zeros of -2, but that -2 has a multiplicity of 2, and then 3 is the other zero. So let's get our factors for this. What are our factors? If -2 is a 0, what's its factor? X plus 2. How many times does that occur? Twice. I can put it squared. What's the other factor? Close. Be a -3 because that's a +3. Let's flip the sign. Remember, change the sign. Now, since A is 1, there's a 1 in front of that, but we don't have to do anything with it, so that shortens it up a little bit. So we want to multiply this thing out. So I need to multiply out x plus 2 times x plus 2, and then times x minus 3. Again, it doesn't matter what 2 you pick to multiply together first. I'm going to pick the 2 that are alike and get those together first. So x times x, x squared, 2x, 2x, 4. That's x squared plus 4x plus 4. X minus 3. And then I'm going to distribute x to everybody. That's x cubed, 4x squared, 4x, and I'm going to distribute -3 to everybody. -3x squared, -12x, and -12. Simplify, and we're finally finished. X cubed plus x squared minus 8x minus 12.
How can you check to make sure that's right? Well, I have a polynomial. I know it's zeros because they told them that's how I built the polynomial. If I graph this, we'll see it crossing the x-axis at the places they told me. Okay, so that's your checking spot. If you can graph that, and if it crosses at the right places, it's the right one. Okay.
right.
Then they start kind of throwing curveballs. Snipers. Knuckleballs at you. Make it look hard. Okay? So they tell us that the zeros are 3 and then square root of 5. What do we know about the polynomials that we've solved that a square root was in the answer? What was always in front? A plus or minus. So they don't tell us that negative square root of 5 is an answer, but it is.
Okay. So this one, you've also got the square root of negative 5 or negative square root of 5. So they didn't tell us that. So this was, I'd call it maybe hidden. They didn't tell us that, but it's there. Okay.
Because we know if a square root was in the problem, there had to have been a plus or minus in front of it. When we solve these polynomials, that always happens.
Okay. So let's get our factors for this one. And again, we're assuming A is equal to 1. What would the factor be for positive 3? X minus 3.
What's the factor for the square root of 5?
X minus the square root of 5. Same idea. You just got the square root on it. And then the negative square root of 5 would be plus square root of 5.
So built the factors the same way. I had the hidden one they didn't tell me about though. Okay. Now, I multiply it all out. I'm going to start with the ones that have the square roots in it because those are the weird ones. And that's the ones I want to get. I want to try to see if I can get rid of those square roots. And they should go away when I multiply.
So when I multiply these two together, x times x is x squared. X times the square root of 5 would be positive x radical 5. And then I'm distributing negative square root of x, or square root of 5. So that'd be negative x square root of 5. And then negative square root of 25. X minus 3. And then I'm going to simplify.
What happens to these square roots here in the middle? They go away. That should happen every time.
They go away. What's the square root of 25? 5. So I really have x squared minus 5.
That's what that simplified down to be, is x squared minus 5. That's a lot better. Now I can multiply this out a little quicker.
So x times x squared be x cubed minus 5x minus 3x squared plus 15. That's not in the right order. It's the right stuff, but not in the right order. So put it in the right order. X cubed minus 3x squared minus 5x plus 15. That's the correct answer.
So again, if there's a square root involved, they don't tell you about all the zeros if they don't have the plus and the minus out of that.
Let's look at this one. All right. Last one we're going to build polynomials with, and then we're going to end up with the last little thing here. It's in behavior stuff. So zeros, negative 4 and 2 minus I. All right. That's a complex solution. Complex solutions always came with what in them? Plus or minus, right? Because they always came from quadratic formula. We didn't have a way to get them the other way, right? So there's always that plus or minus in there. So what's the hidden one? 2 plus I. This is the hidden one that they don't tell us about. We've got to know it's there. Okay. So our factors x plus 4 for the negative 4, x minus 2 minus I, x minus 2 plus I. Flip the sign on the real number part, the 2, that's the minus, and then it's plus or minus with the complex part. Now this one is a little more tedious to multiply out, so it's the last one. That's why I saved it for last, because it's just a little long and boring. But if you'll take it one piece at a time, it's not so bad, okay? Kind of like that Johnny Cash song, build it one piece at a time. Anybody know that song? It's a good song. Always love hearing that song. So x times x, x squared, that's easy. Got that. X times negative 2, negative 2x. Now I got that. All right, good. X times I plus ix. Okay. So I've distributed x to everybody. The next thing to do is distribute negative 2 to everybody. So negative 2 times x, negative 2x. Negative 2 times negative 2, positive 4. Negative 2 times positive I, negative 2i. I've distributed negative 2 to everybody. Last step, distribute negative I to everybody. That'd be negative ix, positive 2i. And what is I times I? I squared. And it's negative I times positive I, so that'd be negative I squared. Woo! That's a long piece of stuff there. All right. Now, when I combine like terms, it gets a lot better. X squared doesn't have anybody else that's an x squared, so I'm just bringing it down. Negative 2x, negative 2x, negative 4x, right? Positive ix and negative ix. What happens to them? They go bye-bye. Gone. Okay? Negative 2i, positive 2i. What do? Bye-bye. Does anybody remember what I squared is? Negative 1. So this is really negative 1. So I have 4 minus negative 1. 4 minus negative 1 would be positive 5. Look how pretty that is. No i's in it anymore. We got it back to the quadratic that those complex solutions came from. It was long. Took a little bit of multiplying. 3, 6, 9, 10, 11, 12, 13, 14. 14 operations to get that part done. Let's finish it up by distributing x plus 4 to that. So that'd be x cubed minus 4x squared plus 5x. This would be, already done the x's. Let's do the 4's. Plus 4x squared minus 16x plus 20. Here's our function. All we got to do is get the like terms together, put it in descending order. So x cubed, negative 4x squared, positive 4x squared. What happens to those? They go bye-bye. Positive 5x and negative 16x be negative 11x, right? And then plus 20. All of that work, and we end up with this little old trinomial here. Out of that. None of the numbers are going to be extremely huge in this. I'm not going to give you big numbers, but when they throw those complex ones in there, it's pretty tough to multiply them together. But if you'll slow down and do it just one piece at a time and put your like terms together, don't get in a hurry. You can. It's doable. All right. Okay. last thing is this idea of what's called end behavior. Okay, of higher degree polynomials. All right. So I'm making a little chart here. And this is how we're going to do this. And then we'll do a couple of examples. And so you got need to know this chart, okay? So there's only two things to know in this chart. Either the degree is odd or the degree is even. Okay? Odd degree, cubic, 5th power, 7th power, 11th power, 37th power, doesn't matter. It's odd. Okay? Even degree, squared, 4th degree, you got a 4 on the exponent, 6, 872. Doesn't matter as long as it's an even number that's the highest exponent in the problem. Okay? The leading coefficient is the number that's in front. Okay? So this is where there are two options. That leading coefficient is either positive or negative. All right? If the degree of the polynomial is odd and the leading coefficient is a positive number, it doesn't make a hill of beans what everything else in the problem is doing. If we're just looking for end behavior and the degree is odd and it's a leading coefficient's positive, just the first term is the only thing you got to look at. If it's positive, the left side's going to go down, the right side's going to go up. Odd degree, positive leading coefficient works like a positive slope. When you think about a linear equation, the degree is 1. That's odd. If it's got a positive slope, it goes up and to the right, down and to the left. That's what an odd degree polynomial, cubic, 5th degree, they all do the same thing. If the degree is odd and it has a negative leading coefficient, it flips it around. Left side up, right side down. Okay. If the degree of the polynomial is even, x squared, x to the 4th, x to the 6th, that sort of thing, and you have a positive number in front, it works like a quadratic. Quadratic equations, remember it was the parabola shape. If it had a positive leading coefficient, it opened up. So the left side went up and the right side went up. If it had a negative leading coefficient, what's it do? Both going down. This is the easiest thing we've done tonight. Okay. So all we have to look at on a polynomial is the first term. And we can decide this stuff. What they're going to do to you on the final exam and on the test and things is they're going to give you polynomials that you can't put in your calculator and graph. They will be so large that your calculator, you can't see the picture. Okay? That's what they do. So that they're measuring, do you know this chart or not? Okay? So let's look at an example of a polynomial. And whatever letter we're on, something like Q. Gosh, it's been there in a while. All right, so here's a polynomial. F of x is equal to 3x to the 5th minus 17x squared plus 11 x minus 816. Okay. The only part, if you're talking about end behavior, the only part that even matters is that. Nothing else. What's the degree of this? 5, which is what kind of number? Odd. So I know the ends are going in opposite directions. What's the leading coefficient? What kind of 3? Positive 3. So the end behavior is left side is going down, right side is going up. The 816 doesn't matter. Nothing else matters. Just the first term. That's an ugly polynomial right there. But if we're talking about end behavior, the first term is the only thing that matters. What's the degree? 4, and it's even. The leading coefficient is negative. So what's the left side and the right side both doing? Down. Even degree, they're always going to go the same direction. That'll help you remember that. Even, they go even directions. They always go the same. Positive up, negative down. That's always what evens do. Okay. Do one more, and we're done. G of x, let's do negative 0.006 x to the third minus 8x squared plus 10.7x to the first plus 104.8. Weird problem because it's got decimals in it, right? We don't see them like that. But bigger picture, if we're just talking end behavior, which is what we're doing here, what's the degree? Odd. So we know that they're both going to go in opposite directions. What kind of leading coefficient do we have? Negative. So what's the left side doing? Up. Right side, down. Know that chart. Those are the easiest questions on the quiz, easiest questions on the test, easiest questions on the final. That and the P over Q list, you probably got 6 or 8 points on the final just by doing those two things. Honestly. Seriously. Okay. All right. So this week you got last two sections here, 3-4 and 3-5, or 3-3 and 3-4. Next week you got tests over all the polynomial stuff. I will send out a review for this test this week, and so next Monday we'll meet. We'll do a couple of quick labs and then the test, and then that's it. And then we'll meet again the next week for our final. When you look at the review for the final, or the practice final that's out there that I sent, if you've got questions about a problem, email me those questions and I will try to put something out there to help you know how to do that problem. It may be I end up doing a video or something and sending you the link to it or sending it to everybody. Okay, so make sure you're looking at that. Don't wait till Sunday to start studying and expect me to be able to answer all your questions between Sunday and Monday afternoon. Okay, so make sure you're starting early on your studying. 3.3 211, 4, 21 through 27. Not many problems with 3. All right.